Hey guys, welcome. Today I want to show you the new solution to the most common performance issue you'll run into in Unity, and that's garbage collection. C# manages our memory for us, which is awesome, and it does this through the garbage collection system. So we can instantiate and destroy things at runtime, and the garbage collection will free up RAM during a cycle where it finds any objects in the scene that are no longer being referenced, and then it frees up that space. But this process can be a little bit slow, and it can cause lag spikes and performance issues with your game, especially if you are targeting mobile or low-end PCs. So we are going to fix these issues in this project by replacing simple instantiate and destroy calls on our projectile with an object pooling system. And at the very end, I'll show you how you can do it with your particle systems as well. So by the end of this video, you will know how to implement an entire object pooling system from start to finish in your own project. Let's get started. Okay, so here is our opening scene here. We have a player that can move, and he has a gun which rotates towards the mouse. And if we hold the mouse button down, then we can shoot. I actually have a great 2D shooting tutorial that you can follow if you want to be able to set up what you basically see right here. So what you are seeing here are projectiles being instantiated every single frame, and then they are being destroyed either when they hit something, or if they go off the edge, then they're going to be destroyed after 3 seconds. You'll see right here that eventually this will all clear up. There you go. Now, I also want to make note of a couple of things. If we click on stats right here and I hold down this button, you can see that our graphics tank to about, seems to be averaging around 100 frames per second. It bounces up and down. And if I release the button, then that very quickly starts to go back up to over 300 frames per second. Now, I've also got the profiler open right here. And if you don't know where that is, you can go to Window, Analysis, Profiler. So I'm just going to let some bullets run for a second, and then I'm just going to click in here, which will pause the game. Now I'm going to sort this by garbage collection allocation here. You can see if we open up the player loop and we follow that all the way down, we are actually using 96 bytes per frame for the instantiate call on these projectiles. And there's 80 bytes here for the garbage collection allocation. Now that might not sound like much, but that is every single frame. And that's definitely something that we're going to want to improve. Even if you're targeting high-end PCs, it's still worth doing the work to improve this by implementing an object pooling system, because we always want our games to be running as smoothly as possible. So let me just quickly show you what we're working with here. The only script we're going to care about on the player is the player aim and shoot script. What we care about is the handle gun shooting. And what we are going to do in this tutorial is replace these two instantiate calls. This one is instantiating the actual bullet, and this one is instantiating the particles that you see coming out of the player's gun when he shoots. We are going to replace both of these with an object pooling system. So where are we going to start with this? So there are two sides to this that we want to change, right? We want to change the instantiate call. So let's just take a look at the bullet for a second. So we are instantiating this bullet, and that is a prefab object right here. And if I open that up and go into my bullet script, again, there's a whole bunch of functionality here that doesn't really matter for the object pooling tutorial. There's some damage being applied and some gravity being applied. But the two things we care about in this script are the destroy calls. So there's one right here. We call destroy on this game object after destroy time, which I have set to 3 seconds if it doesn't hit anything. And if it does hit something, then we are just destroying the game object. So in order to replace an instantiate and destroy process, we need to replace the instantiate call and these destroy calls. So this is going to take more than one line of code to replace this instantiate line here. It's a little bit more work to set up an object pooling system, but it is so worth it for the performance of your game. So in order to handle the actual spawning of the bullet, I'm actually going to create a new script called bullet spawner. And I'm going to put that on my player game object and open that up. So let's actually set up the object pooling system now. So in order to start, we want to grab a reference to the object pool class. And in order to do that, we need to go up here and add the using Unity engine.pool namespace. Now that we have that, we can actually go in here and say public object pool, and it needs us to pass in a type. And you could put a game object in here in order to instantiate a prefab, which is essentially what I'm going to do. I just also want to grab a reference to our bullet script at the same time. So I'm going to pass in bullet, and then we're going to call that pool. Now let's create a start function. And let's actually declare this and set it up. So we are going to say pool is equal to new object pool of type bullet. Okay, so now we've got a whole bunch of things that we need to set up. It needs a create function. It needs an action on get, an action on release, an action on destroy. It needs a value for collection check, default capacity, and max size. And for the first 4, I'm going to set up methods for those. So I'm just going to comment this out for a second. So let's make the create function first. I'm going to call this private bullet create bullet. Now, what is this function? Well, this is essentially going to be the function that tells the object pooling system what to do if there are no objects in the pool. Because the way that an object pooling system works is instead of just instantiating or spawning and destroying when you need stuff, you're going to have a large collection or a pool of these objects that you want. It could potentially be hundreds that are just sitting in your hierarchy, inactive, waiting to be used, so that when we need one, it will simply just activate it. But if there's no pool already in existence, then we need to tell the object pooling system what to do. So if there's no pool already set up, well, then we need to actually create a bullet, which will involve an instantiate call. And that's necessary only once, just to actually set up the pool. And it might actually be worth it for your project to preload or pre-spawn a whole bunch of instances or create your pool at the start of the game. And that's something that you could set up in the start function. But for this tutorial, I want to keep it simple, so I'm not going to do that. We're just going to create them as we need them. So we need to grab a reference to bullet. So I'm going to say bullet. We'll call that bullet is equal to instantiate. Now we need to tell it what to instantiate. And currently right now, if you look in my inspector, I want to instantiate this bullet object right here, which is actually sitting in my player aim and shoot script. So I could move this bullet over to the bullet spawner over here. We could do that, but I'm just going to grab a reference to the player aim and shoot and just grab the bullet from there directly, because I just kind of like having all these references in one place on my player aim and shoot script. So I'm going to grab a reference to this and just grab the bullet from there. So back in our bullet spawner script, let's say private player aim and shoot. I'm going to call that player aim and shoot. Let's grab a reference to that in our start function. And they're both just sitting on the player, so I can just do get component, player aim and shoot. So now back in our instantiate function, what are we instantiating? Player aim and shoot dot bullet. Okay, and I also need to pass in the transform as well as the rotation. So what I'm actually going to do is go back to my player aim and shoot and look at what we did there. Well, for the transform position, we said the bullet spawn point dot position, and for the rotation, we said the gun dot transform dot rotation. So let's just copy that over here. Player aim and shoot dot bullet spawn point dot position. And for the rotation, player aim and shoot dot gun dot transform dot rotation. Now you can see that I've got an error here. That is because I'm passing this in as a type bullet, but over here in my player aim and shoot, bullet is actually set up as a public game object. So while we're in here, let's just go ahead and comment this out because we don't want to use that anymore. And let's go up here and change bullet to bullet instead. And if we change the type, we're going to need to go back into the inspector and reassign it. So you can see we changed the type. Now it says type mismatch, but I can just drag that back on there again. Okay, and now that error is gone over here. Okay, so almost done with this function. So what do we do when we're trying to use the object pooling system, but there's no pool set up? Well, we're creating a bullet by instantiating a new bullet. So the way that this object pooling system is going to work is that these objects are going to be added back into the pool and deactivated at the place where we would normally destroy them. And we are destroying the bullets in the bullet script over here. There's one right here and one right here. So we know that these two scripts are going to be dealing with the same pool. So to make this easy, I'm going to set up a public method in the bullet script called public void set pool. And we're going to pass in, we want to pass in an object pool, but I need to add the namespace up here first. Using Unity Engine.pool, there we go. Now I can go down here and add an object pool. Again, it's going to be of type bullet, and let's call that pool. Let's also go up to the top here and add a private object pool. Bullet again, call that pool. Okay, now we can go down into set pool, and we need to point to what this pool is. So what we're going to do is go in here and say underscore pool is equal to pool, which is this one right here, which we are going to pass in and call this set pool right here in our bullet spawner. Okay, so I actually don't need to grab a reference to the bullet script because we have it right here. So I can just say bullet.setPool. What's our pool name? Well, it's this one here, which we are setting up right here. Okay, so now we actually have an object pool set up in our bullet script, which we are going to need, and it is now pointing to the same one that the bullet spawner is because of this little method here, which is great. And finally, to get rid of this error, we need an actual return type because we made this a private bullet. So let's say return bullet. Okay, so if we go back up here, we can now add our create bullet method as the create function. Now it wants an action on get, and I'm going to create these at the same time. The action on get, the action on release, and the action on destroy. Those are all very, very easy. So the first one is going to be a private void on take bullet from pool. I'm going to pass in bullet called bullet. So this is literally what do we want to do when we take an object from our object pool. So what do we want to do when we take an object from our object pool? Well, if we don't have an object pool, then we are instantiating a bullet at the bullet spawn point and at the gun's transform rotation. Now, if we actually have something in the pool, we're going to want to re-enable that game object, but we're also going to want to reset its transform position and its rotation. Otherwise, it's just going to be re-enabling in the exact same place and at the exact same rotation that it was at when it was deactivated in the first place. So we'll set the transform and rotation, and then we'll activate the game object. So we've already got a parameter of type bullet here, so we can say bullet.transform.position is equal to player aim and shoot .bullet spawn point .position, and the rotation, I'm actually going to do that by setting the transform.right directly, is equal to the player aim and shoot .gun.transform.rotation. Sorry, gun.transform.right. Then to activate it, we'll finally say bullet.gameObject.setActive true. Okay, so we can add on take bullet from pool up here. Now it wants an action on release to be created. Let's set up a new method called private void on return bullet to pool. And we're going to pass in bullet called bullet. So when we actually want to return it to the pool, there's nothing else that we need to do except to deactivate it. That's literally all we need. So we can say bullet.gameObject.setActive false. Now we can go up here on return bullet to pool, and we need an action on destroy. Well, why does it need to destroy anything? Well, that's because the way that this function works is the pool will always spawn objects. Okay, it's always going to spawn them, even if it puts us above the maximum pool threshold. You'll see that this function is going to ask us for a default capacity and a maximum capacity in just a minute, but it's always going to spawn objects, even if it puts us above the max that we set. But what it'll do is once it's going to return the object to the pool, if the pool is already at maximum capacity, which we will manually set. If it's at maximum capacity at that point, then it will destroy the game object instead of returning it to the pool. So it still has instantiate and destroy built in, but we can manually assign the size that we want this pool to be. And you'll want to play around with the numbers because really you can think of an object pool as like a big array. And let's say if we have an array that holds 100 objects, even if that array is empty, if you set it to have an array of 100, then it's going to allocate that much memory from your RAM for those 100 objects. Well, an object pooling system is very much the same. It takes the memory even if it's not being used. So we want to tweak those values to be around what we expect the normal to actually be at. It doesn't make a lot of sense to have an object pool with like 1,000 objects in it if you're only ever going to have like a maximum of 5 or 6 in your scene. That just doesn't make any sense. So we can save ourselves a little bit of memory by being smart about those numbers. But hopefully that makes sense. That is why even though we're trying to replace an instantiate and destroy call, we still need instantiate and destroy calls because this function has that functionality built in where we can manually control the size of the pool. So let's go down here and finally set that up. Call that private void on destroy bullet. Okay, so literally that's just going to be destroy bullet.gameObject. Okay, and we can go up here and for our action on destroy, pass in on destroy bullet. Okay, now we're on our collection check. So I'm going to set this to true, but what this is this makes sure that you're not able to return something to the pool that's already been returned to the pool. This function has a check for that because that could result in a lot of errors. But if you are absolutely 100% sure that your code is going to work and there's not going to be any problems, then you can set this to false and it'll be even faster by saving some CPU cycles. But I'm going to set that to true because I like having checks put in place. Okay, so now we're at default capacity and max size. And this can be a little bit confusing for people. It certainly confused me at first, but I find it easiest to think about this, the default capacity. Think of that as your array size for your pool, your typical size that you think you're going to need. Now I'm spawning projectiles into the scene every single frame, so mine should be hundreds and hundreds because I'm not destroying the bullets for like 3 seconds and my game runs at about 200 to 300 frames per second. So I'll probably want something around 1,000. That's kind of my expectation for about the size of the array that I might need. Now, if that's the case, we've set our default capacity. What the heck is the max size then? So if you think of default capacity as the size of your object pool array, your max size is how much your array can actually expand by. So let's just say for the sake of example that I put 2,000 in here as our max capacity. What that means is it's going to create an array the size of 1,000. It's going to hold memory for enough objects for 1,000. And if it needs 2, it can expand by instantiating new ones and then adding them into the pool when they are released and increase the max size of this array up to potentially 2,000. If I make this 1,000, then we can still have more than 1,000 projectiles being spawned into the scene. It's just any bullets that are over the 1,000 count, they are not going to be returned to the pool. They will be destroyed instead. So I hope that makes sense. But now we have this all set up. So how the heck do we actually replace this instantiate call now with the object pooling? Well, first let's grab a reference to our bullet spawner script. Just going to call that bullet spawner. Let's grab a reference to that in a start function. Bullet spawner equals get component bullet spawner. There we go. Now down here, instead of this instantiate call, we can just say bullet spawner dot pool dot get. And that is literally it. Now I am going to test this, but I do expect to see some problems. Let's see what happens. So actually there's no problems happening, and I forgot. That's because I haven't actually replaced the destroy calls yet. So this is actually working exactly the same as it was before with the exact same performance problems. We're basically we just set up a very fancy way of instantiating these bullets into the scene. So let's actually finish this first. So we replaced this here instead of our instantiate, but none of those are getting returned to the pool because in our actual bullet script, we still are destroying the game object instead of returning it to the pool. So what's great is because we already set the pool in here, this already is linked to the pool in bullet spawner. So actually I can come in here and comment out that destroy call and say pool.release this. Okay, so that's that one taken care of. Now we also have this one here that destroys the game object after destroy time, which is 3 seconds. What I'm going to do instead is create a small little coroutine to handle that with the object pooling instead. So let's create private coroutine, destroy bullet after time coroutine. Okay, now I'm going to go down here, say private IEnumerator. Actually, this shouldn't be destroy, this should be deactivate. And I'll call this deactivate bullet after time. So I'll set up a float called elapsed time and default that to 0. And we'll say while that elapsed time is less than our destroy time. Then we'll iterate the elapsed time plus equals time.delta time. Yield return null to make it wait till the end of the frame. And then after that timer is over, we'll again say pool.release this. And now let's actually call this coroutine from our start function. So we'll do that by grabbing that, say that is equal to start coroutine, deactivate bullet after time. Okay, so we have replaced the instantiate calls and the destroy calls now. Let's give this a test. There's the problem I was expecting. Okay, so our bullets are not behaving the way that I would expect. And the reason for that is because of what's going on in our bullet script. When you just instantiate and destroy things, it's fine to just grab things once in your start function. But when you're reusing a prefab over and over and it's being deactivated and activated instead of instantiated and destroyed, well, we just need to change a couple of things about how this works. For example, grabbing our rigid body component, that is fine to stay in start. We only ever need to grab a reference to that one time. However, this deactivate after a timer coroutine, that is going to need to be reset every single time that the bullet gets activated. So let's create an onEnable function. So onEnable actually gets called right after awake, even before start, but onEnable also gets called every single time that the object is enabled. So let's move this into our onEnable function. Here I'm actually applying some gravity to our bullets, which is really just changing the rigid body's gravity scale. So that also is fine to only be called once. But if we look at set physics velocity, that is currently, because it's in the start function, the very first frame that it was instantiated, it's setting the velocity of the rigid body to be in the direction that it's looking multiplied by speed. So this also needs to be moved into onEnable instead. That's why our bullets were not behaving the way that we expected. Let's try that out now. Okay, and this is where the order of execution comes in really handy. I should know better because I literally just showed you that onEnable is called before the start function. And yet if we go to our bullet script, the change that I literally just made is to grab the rigid body component in the start function for the very first time. But we know that this is actually called first, and it's trying to apply velocity to a rigid body that it doesn't have yet. So actually we should change this to awake because nothing is called before awake. So that will now grab the rigid body component and be able to properly set the physics velocity. Let's try that one last time. Okay, there we go. Bullets are behaving as expected, and you can also see over in my hierarchy over here Got this long list of bullet clones here, and you'll see them randomly activating and deactivating based on their needs from the object pooling system. So based on the size of my scroll bar here, it looks like it is having to instantiate and destroy a couple of things every once in a while. So we're probably very, very close with this 1000 here, but what I'm actually going to do is increase our maximum size to 1500 just to be safe. Okay, awesome. Now let's do the same thing with these particles that are shooting out of the gun. So that you can see how that works, back in our player aim and shoot, we are literally just instantiating particles at the bullet spawn point and at the gun's transform rotation. Very, very much the same as our bullet. Now these particles are being instantiated. And then you can see that our stop action within the actual particle system, when it stops, it destroys itself. Okay, so basically this is also an instantiate and destroy scenario, and we want to replace this with an object pooling system as well. So what we're going to do is something very, very similar. We're going to set up a particle spawner script. I'm also going to add that to my player and open that up. So we first need to add our namespace. Then we want to set up a public object pool. This time it's going to be of type particle system, and we'll call that particle pool. Now we already know that we're going to need to do a create function, and that's going to need to have an instantiate call that also needs the bullet spawn point and the gun's transform rotation. So I'm also going to need a reference to the player aim and shoot in this script as well. We'll call that player aim and shoot, and we'll grab that in our start function. And this script is attached to the player, so we can just do get component. And I am trying to get into the habit of doing proper naming conventions, but I keep forgetting. There, I'm going to add an underscore to that. Now let's actually set up the particle pool. That's going to be equal to a new object pool of type particle system. And now again, we need to create a create function, an action on get, an action on release, an action on destroy. So let's just very quickly set all of those up. So we're going to say private particle system called create particles. We'll need an action on take. So private void on take particles from pool. And we'll pass in a particle system called particles. And now we need an on release function. So let's set up private void on return particles to pool. And pass in particle system called particles. And we need an on destroy action as well. So we'll call that private void on destroy particles. Pass in particle system, and again, call it particles. So I'll fill these in just a second. So what we're going to do is pass in create particles. We'll pass in on take particles from pool, on return particles to pool, and on destroy particles. I will keep collection check set to true like before, and I'll also use my same numbers, 1000 and 1500. Okay, so there's that. So let's actually fill these in now. So we'll set up a particle system called particles is equal to instantiate. What are we instantiating? We are instantiating the player aim and shoot particles right here. So we'll say player aim and shoot dot particles. What's the transform parent? Well, that's player aim and shoot dot bullet spawn point dot position, and the rotation player aim and shoot dot gun dot transform dot rotation. Okay, and then we just need to return particles. Next, when we want to actually take an object from the pool, kind of like instantiate works, we are again going to want to set the transform position and the transform rotation, and then enable it. So particles.transform.position is equal to player aim and shoot dot bullet spawn point dot position, and particles.transform.right is equal to player aim and shoot dot gun dot transform dot right. And then we'll actually activate the game object. We'll do that by saying particles.gameObject.setActive true. When we want to return them to the pool, we're simply going to deactivate them. Particles.gameObject.setActive false. And to destroy them, we're just going to call destroy particles.gameObject. So now let's actually handle replacing this instantiate call in the player aim and shoot before we handle replacing the destroy. So let's comment this out. What we're going to need is a reference to our particle spawner script. Go up here, say private particle spawner. And I know I'm forgetting the underscores again here, but none of the rest here have them, so I'll try to do better going forward. But for now, let's just grab this and say that is equal to get component particle spawner. Then finally down here, we can say particle spawner dot particle pool dot get. Okay, now this is not actually going to be a proper object pooling system until we replace the destroy call. And you'll remember if we go into this particle system, we have our stop action set to destroy. What we're going to want to do is change that to callback. And I actually need to set up one last script and attach it to this particle system. I'm going to call that particle pool. Okay, let's open that up. So I want to add the pool namespace again. So I want to set up a private object pool of type particle system called pool. Now I actually want to assign this pool to be the same pool as our particle spawner pool. Now this particle pool script is attached to a prefab particle system game object. So I can't just do a get component and grab it from the particle spawner. Now it's not the fastest call in the world, but we are going to say pool is equal to GameObject.FindGameObjectWithTag. Let's find the player tag. Let's also make sure that our player is tagged as player. And we'll finish that by saying .getComponent, particle spawner, particle pool. So that's not the fastest, but I do have to have particle pool set up on top of our particle pool object. And that's because I need to call the onParticleSystem stopped function. And as you can see here, this is called when all particles in the system have died and no new particles will be born. So when this particle system is completely done playing, well, then we want to say pool.release. And what do we want to release? We want to release the particle system. So let's actually just grab a reference to that very quick. Private particle system, call that particle system. Let's grab that in our start function. Particle system is equal to get component particle system. Now we can say release the particle system. Also, it might be worth setting the particles to callback in the code as well. This is totally up to you, but I am very, very likely to forget to set the stop action to callback right here. So this is completely optional, but I'm going to set it in code. I'm going to create a variable called particlesystem.mainModule. We'll call that main, and that's equal to our particlesystem.main. And then you can say main.stopAction is equal to particlesystem.stopAction.callback. And you know what? I can't do this. I cannot do it this way. It's too slow. I'm going on the fly here. But what I actually want to do is we set up a bullet.setPool right here. I would like to do something similar to that with our particles as well. So in our particle spawner, when we actually create the particles, let's assign it there. So let's go to our particle pool and set up a public method. Public void set pool. That's going to take in an object pool of type particle system called pool. And we'll say our underscore pool is equal to our pool. Just going to delete that. Now back in our particle spawner, now I've kind of got two options. I could actually use a get component call from this particle system and grab the particle pool script, or I could actually change this to particle pool instead of particle system. Let's try that. What the heck? Let's say particle pool instead. Copy that and put that here and here and here and here. And here and here. That's going to give us an error here. That is because our player aim and shoot is a public particle system. This should be a particle pool. And again, back in our inspector, it will be a type mismatch again, but we can just drag that on there. Now I don't need to do a get component to find this because it's already being referenced right here in our object pooling system. So I can just say particles.setPool. What are we setting it to? Our particle pool. And that's going to give us an error because we need to go into particle pool and change this to a particle pool instead. And same with this. And since we're calling pool.release in the particle pool script, we can just change this to this. Okay, now we got rid of that awful tag call, which is going to slow things down. And instead, we're just setting the pool directly right here when we actually create the particles in the particle spawner script, which is, in my opinion, a lot cleaner and a lot nicer. Okay, so let's give this a test. There you go. Particles are working as intended. You can see now we've got a whole bunch of bullet clones as well as a whole bunch of particle system clones. Our frames per second have jumped up by about 20 to 25 frames per second. And if you take a look at our profiler now, the instantiate call is now gone entirely. We have a few bytes being allocated to GameObject.activate, but that cannot be helped. But our goal was to get rid of instantiate because that is not necessary when object pooling systems are available. So we have successfully decreased the amount of bytes that we are using on every single frame, which is resulting in a higher frame rate on average. There you go, guys. Thank you so much for choosing this tutorial to learn about object pooling. It really, really means the world to me. Please let me know in the comments below if you found this tutorial helpful or if there's anything that you would add or change. I always love hearing from you guys, and I'm working very hard to grow this channel, and I really want YouTube to like me more. So if you found this video helpful to you in any way, then please give it a like and consider subscribing. Thanks, and I hope that you have an awesome day. Bye.